So, hello and welcome back to my C++ tutorial playlist. In this video, we will take a look at how to add tests using the Catch2 testing framework to our program, the Quest Tracker, because we have ignored testing for the longest time. Unfortunately, a lot of recording got lost, but I think it makes sense if I walk you through it very quickly anyways. So let's first of all take a look at how to set up Catch2. And as you can see here in our cmake, we've added a testing section and we test here if we are on the Linux system. This is important for GitHub Actions because we only want to build testing and run the tests on the Linux system. And for the other platforms like Windows, we just want to provide a build. And then if we have the build testing switch enabled, then we add a subdirectory called tests. So let's take a look into here. And in here, as you can see, it's very simple. We just add an executable called tests. Then we add the source for our tests here. And then we include all the functionality that we want to test from our main application to also get linked. And that will produce our test binary. And then to add Catch2, we just add this line here with CPM. And also we want to include CTest because that is the that we will use to run the tests and to provide us with more information about the tests. And here to use Catch2 and download it and so on, we just provide it here with this shorthand notation, just gh for GitHub, then colon, and then catch.org/catch, and then Catch2, and then add the following version tag. And then after that, we want to link it to our tests application. And we also need SQLite to access our database for testing purposes, like that. And we already have defined the SQLite CPP target in our root level cmake lists, so we can link it here just easily as that. Then here we need enable testing. I don't think that's needed, but I want to do it explicitly anyways. And here we can use the functionality from CTest to add test cases, and we name this unit tests and provide our tests target here. So if we had multiple executables, we could give them a different name and run them each with the CTests also. So let's say we would have a different target. We could name this integration tests, for example. And then, of course, we would then provide the integration tests target. And of course, we would then also need to specify a new executable target, but we don't want to do that right now. So now that we have seen how the cmake for everything looks like, let's take a look at how the test cases look like. Here we can see we include the header for the functionality we want to test, which is here the task list. And then we want to define, before we include anything from Catch2, that we want to define catch config main, which means that we want to have a configuration with a main function. So if we run it from the console, that is a fully functional program with a main function and doesn't need to get linked to a program with a main function. That is usually what we want. Here we then have the usual includes for the things we want to test. Basically here SQLite to access our database, then asserts, and then file system and memory for the functionality from there. So let's go here. For every test we want to write, we use this test case method macro, and then we can provide here a fixture with all the setup that has to be done before we can do our tests. So in here we make sure that we have a task list, and we also make sure that there's no remaining test database file. So we always start with a blank one, so we always have the same starting condition. And then here on the right side, we give this test case a name, and then right to that we can give it a category, and we just name this task list. And in here we can have different sections for different operations that we want to test. So for example, we here have a section for adding a new task. And here we just make some defines for the title, state, description, and category. Then we assign it here to the task. Then we add the task to the task list. And then we require that the task has been added correctly, and the task list that we get from get tasks is now contains exactly one entry. Then after that, we test if the task is actually the one we put in by asking if the title is still the title that we set, if the state in the task that we received is still the state that we've set initially, and the same goes for description and category. And in here, we go through the objectives. Here we have the list of the objectives that we've set, and we make sure that pay is still in here. Ideally, we would test for any one of them, but we don't want to assume any order because it's not important for us if it gets stored in a different order. So we don't want to test it, but we would need to test if all of them are still in there here at this point. And here in the other section, we just want to make sure that an empty task list is still empty. So how to run our tests? We build the application as usual. And then after everything is built, we can go into our build directory. And now we should see that we have a tests directory here also, not only a bin directory. And in here we have a tests application that we can run. And as we can see, we completed all tests. But what we usually want to do is to run CTests. And that will run also all the tests for us. And as we can see, everything worked here. And what are tests actually useful for? That is that we have an automatic way of testing that everything still works. So for example, we change a lot of functionality in our app, and we don't want to retest everything manually that we had done previously. And test cases like this can be run automatically, also in our GitHub Actions file. So we go here into GitHub Workflows. And as you see here, after we've built everything here, we have a new step in our GitHub Actions file where we go in our tests directory as we've done right now. And then we run CTests here to actually run the tests for us automatically. And if the tests fail, then our pipeline will also fail, and we will prevent that we ship a broken build or a broken product. So after that, we will see that something went wrong and we can fix it before we ship it. Otherwise, we will go to the next steps and package the binary and deploy it. Another thing I wanted to mention is here in the tests. Previously, I was a little bit lazy, and in a video where I covered CTest, I did something like this. And this works if we want to test for things that are private in a class that we included. This is a quick hack to test something that is private, but it should ideally never be done. And this should always be a sign that something in the class we want to test is wrongly designed. And a more elegant way or a better way to go around this would be to outload the functionality we actually want to test into a new header as a free function, and then just use that in a private method so we can also test it from the header that we can include here, and then only include that header in the C++ file and then also include it here so we can easily test it, but we still don't have to do anything hacky with the preprocessor. So that if we have to do something like that, it's always a sign that something is wrongly designed. But if you are lazy, you can still do that, because I'm a little bit pragmatic here. As long as we get the functionality we want from tests here, which is actually like a canary or like a warning that something is broken. As long as we get that, I think whatever we do here in the test is fine. Of course, we also want to write proper tests, but as I see it, this doesn't ship in the final code. This is only a useful tool for us to know if something broke, so we can fix it then. And we are aware of it. So the question is always, how can we make this do as much work for us as we can and not get mangled up in a huge redesigning effort that would otherwise not be necessary. So much for that. And so when we have defined the testing step here, then this will run every time we push to our main branch on the GitHub repository, and this will run automatically, and we will get informed if something breaks. So we don't run in any risk that we might accidentally break something if we have a good test coverage. So much for that. We will make use of tests more and more in the following projects. This was just a very short introduction. Thank you very much for watching and see you in the next video.